All right, guys, I wanted to give us, and focus it here, a little heads up about the domain and range on the absolute value function. So what we're looking at here is the parent function for the absolute value, which is f of x is the absolute value of x. It's got a vertex right here at the origin. On the right, the slope is 1. On the left, the slope is -1. It makes that nice little V shape. So you're going to be asked on a lot of these to identify the domain and range. So it's really important that we're clear on what they mean. The domain is basically looking at the x values, the input, what we can plug into the function. So it's this axis right here. And there's a couple different ways you can think about it. You can actually sort of look at the equation itself and say, what can I plug in for x? And in this case, there's no restriction. I can plug in positive numbers, negative numbers, fractions, decimals. You can also think about it visually and sort of ask yourself, where are these, I'm going to put arrows on the end, where are these lines growing? And will they cover the entirety of the x-axis? So they are growing up and to the right. They are forever going this way and forever going this way. Coordinates on this line will include any x value that is positive and then also any x value that is negative. So because I can plug anything in here, there's no restrictions on what I can input. And because I can see visually that these lines are going to forever go left and right, my domain is that x is all real numbers. It basically means I can plug in whatever I want. There is no restriction. Okay. I'm going to look at a couple here, or we'll look at a couple more after this, but I want to finish with the parent function here talking about the range. The range now is going to take a look at the outputs. So it's basically going to be your y values. We're going to look at this in terms of the y-axis. And this is really nice to see visually. It's a little bit harder to think of with the equation, but with the graph, it's really nice because we're looking at the y-axis. And we want to know what's going to come out of this function. Well, this thing has a vertex here at the origin, and it is forever growing up. So you can see it kind of highlighted the top of this y-axis because I know these lines are only going to go up. I'm never going to get any outputs here. Every coordinate on this line is going to have a positive y value. I can never get a negative y value because this is the bottom and it's growing up. So for the range, it's a little bit different. It's going to start as all real numbers, but it's going to have a little qualifier on it. We're going to say, I'm just going to say the y for now, the outputs, right? I could say f of x as well. The y is all real numbers. Be lazy and write that. But there is a caveat here. There's a but. It's got to be 0 or greater. Greater than or equal to 0. So remember, domain and range are just sets of numbers. They are groups of numbers. And often the group is everything. It's all real numbers. We can plug anything we want in for the domain. But sometimes there are restrictions. And this is a really good example of a restriction on a range. The outputs are only ever going to be positive, right? If I plug anything in here into the absolute value of it, the only type of number I'm going to get out is going to be a positive number. So my range has to be real numbers greater than or equal to 0. So let's just take a look real quick on a couple absolute value functions where they've been shifted around a little bit. Let's see if I can get this where we can see it well. There we go. I want to see the graph and room for the domain and range. Okay, so for this one, the domain, this graph has been shifted off the vertex, just 1 unit left and 2 units up. But the lines are still going forever from the vertex left and right, which means as this thing grows this way, it's going to hit all these values of x. They will all be coordinate values or half of coordinate values on this line. And it's going to do the same thing going this way. There will never be a portion of the x-axis that isn't represented on a coordinate here. So the domain is going to be x is all real numbers. And we'll talk about a way to notate this a little bit shorter, but for right now, we'll just keep it in sort of a standard English explanation. X is all real numbers. The range, however, we can see that this thing has been shifted up to 2. So now the only y values that we're ever going to see on that graph are going to be 2 and higher. Meaning if I ever did a coordinate here, like this is the coordinate 1 and then 4, right? My y value is a 4, but I can never get a coordinate where I have a y value of -4 because the absolute value graph won't go down here. So my range is that y is all real numbers, but now we have to be greater than or equal to 2. greater than or equal to 2. It's going to stay at 2 and above on the y-axis. Okay, so we can do the domain and range for this guy here. There we go. Now I got room to write. So same thing here. It should be starting to feel a little bit easier now. This red line, the red V, the absolute value thing, is going to go forever to the left, forever to the right. We got no restrictions on x. This is, x is all real numbers. X is all real numbers. Okay, now for our y-axis, this guy's been shifted up to 2 as well, but this time it's going down. So now on the y-axis, we're only going to be 2 and below. So the y, the range, the outputs, however you want to think about it, the y values are all real numbers less than or equal to 2. And that's it. We're just describing the set of numbers that are inputs, which are the x values, and the set of numbers that are y values, that are the outputs. All right, hope that's helpful. Message me anytime.